When replacing a capacitor on an air conditioning blower motor where the original rating is gone, several steps can be taken to determine the correct microfarad range. Firstly, identify the blower motor model. Look for a label or nameplate attached to the blower motor. If the original label is missing, you may be able to find the model number stamped into the motor housing. Secondly, use the manufacturer's website. Visit the website of the blower motor manufacturer. Search for the blower motor model number. If successful, you should find a product page that includes the capacitor range. Thirdly, contact an heating, ventilation, and air conditioning technician. If you are unable to find the model number or manufacturer's website, contact an heating, ventilation, and air conditioning technician. They can inspect the motor and blower and determine the appropriate capacitor range. In many regions, the estimated capacitor range for most heating, ventilation, and air conditioning blower motors can vary. Typically, run capacitors are in the range of 2.5 to 6 microfarads. Start capacitors usually fall within the range of 50 to 150 microfarads. It is imperative to consult a qualified electrician or heating, ventilation, and air conditioning technician before attempting to replace the capacitor. The capacitor must be rated for the correct voltage and frequency. Using oversized capacitors can damage the motor, while undersized capacitors may not provide sufficient starting power. Understanding the role of capacitors in blower motors is crucial for proper maintenance and repair. Capacitors are electrical components that store energy and release it during motor startup and operation. They play a vital role in providing the necessary torque to start the motor and maintain its efficient running. There are two main types of capacitors used in blower motors: run capacitors and start capacitors. Run capacitors are designed for continuous operation and are responsible for maintaining the motor's efficiency while it is running. They provide a steady flow of current to the motor windings, ensuring smooth and consistent performance. These capacitors are typically smaller in capacitance value, usually ranging from 2.5 to 6 microfarads, as they only need to provide a small amount of current to keep the motor running efficiently. Start capacitors, on the other hand, are used only during the motor's startup phase. They provide a large burst of energy to overcome the initial inertia and get the motor spinning. Once the motor reaches a certain speed, the start capacitor is automatically disconnected from the circuit. Start capacitors are much larger in capacitance value, typically ranging from 50 to 150 microfarads, to deliver the high current needed for starting. When a capacitor fails, it can cause various problems with the blower motor. A failed run capacitor can lead to reduced motor speed, increased energy consumption, and overheating. In some cases, the motor may not start at all. A failed start capacitor can prevent the motor from starting, resulting in a humming sound, but no movement. Identifying the correct capacitor for a blower motor involves matching the capacitance value, voltage rating, and physical size. The capacitance value, measured in microfarads, must match the original capacitor's value to ensure proper motor operation. The voltage rating must be equal to or greater than the motor's voltage to prevent capacitor failure. The physical size of the capacitor must also be compatible with the available space in the motor housing. When selecting a replacement capacitor, it is always best to consult the motor manufacturer's specifications or seek guidance from a qualified technician. Using the wrong capacitor can lead to motor damage, reduced efficiency, and potential safety hazards. In addition to capacitance and voltage, it is also important to consider the capacitor's operating temperature range. Blower motors often operate in high-temperature environments, so the capacitor must be able to withstand these conditions without degrading or failing. Capacitors designed for high-temperature applications are typically more expensive but offer greater reliability and longevity. Another factor to consider is the capacitor's tolerance, which is the allowable variation in capacitance value. Capacitors with tighter tolerances are more precise and can provide better motor performance, but they are also more expensive. For most blower motor applications, a tolerance of plus or minus 10% is acceptable. Installing a new capacitor in a blower motor is a relatively straightforward process, but it is important to follow safety precautions to avoid electric shock. Firstly, disconnect the power to the motor before working on it. Secondly, discharge the old capacitor using a resistor to eliminate any residual voltage. Thirdly, carefully remove the old capacitor and install the new one, ensuring that the polarity is correct. Finally, reconnect the power and test the motor to ensure that it is running properly. If you are not comfortable working with electrical components, it is best to hire a qualified technician to perform the capacitor replacement. Attempting to repair or replace a capacitor without proper knowledge and experience can be dangerous and may result in injury or damage to the motor. Proper maintenance of blower motor capacitors can extend their lifespan and prevent premature failure. Regularly inspect the capacitors for signs of damage such as bulging, cracking, or leaking. Clean the capacitors to remove any dirt or debris that may be affecting their performance. Avoid exposing the capacitors to extreme temperatures or moisture, as these conditions can accelerate their degradation. By following these simple maintenance tips, you can keep your blower motor running smoothly and efficiently for years to come. In summary, replacing a blower motor capacitor requires careful attention to detail and a thorough understanding of electrical safety. By identifying the correct capacitor specifications, following proper installation procedures, and performing regular maintenance, you can ensure the optimal performance and longevity of your blower motor. Remember to always consult a qualified technician if you have any doubts or concerns about the capacitor replacement process. Capacitors are crucial components in air conditioning blower motors, providing the necessary energy for starting and maintaining motor operation. When a capacitor fails, it can lead to various problems, including reduced motor speed, increased energy consumption, and complete motor failure. Therefore, it is essential to understand how to diagnose and replace capacitors to ensure the efficient and reliable operation of your air conditioning system. Firstly, let's discuss the types of capacitors commonly found in air conditioning blower motors. There are two main types: run capacitors and start capacitors. Run capacitors are designed for continuous operation and are responsible for maintaining the motor's efficiency while it is running. They provide a steady flow of current to the motor windings, ensuring smooth and consistent performance. Start capacitors, on the other hand, are used only during the motor's startup phase. They provide a large burst of energy to overcome the initial inertia and get the motor spinning. Once the motor reaches a certain speed, the start capacitor is automatically disconnected from the circuit. Now let's move on to diagnosing capacitor problems. There are several symptoms that may indicate a faulty capacitor, including a humming sound from the motor, a slow or delayed motor startup, and a complete failure of the motor to start. In some cases, you may also notice physical signs of damage, such as bulging, cracking, or leaking. To confirm whether a capacitor is faulty, you can use a multimeter to measure its capacitance. A capacitor's capacitance is measured in microfarads, and the reading should be within the manufacturer's specified tolerance range. If the capacitance is significantly lower than the specified value, or if the multimeter shows an open circuit, the capacitor is likely faulty and needs to be replaced. When replacing a capacitor, it is crucial to select the correct replacement. The replacement capacitor must have the same capacitance value, voltage rating, and physical size as the original capacitor. Using the wrong capacitor can lead to motor damage, reduced efficiency, and potential safety hazards. To find the correct replacement capacitor, you can refer to the motor manufacturer's specifications or consult with a qualified technician. You can also use online resources such as capacitor cross-reference charts to find a compatible replacement based on the original capacitor's part number. Before replacing a capacitor, it is essential to disconnect the power to the air conditioning system and discharge the old capacitor to prevent electric shock. Capacitors can store a significant amount of electrical energy even after the power is turned off, so it is crucial to take precautions to avoid injury. To discharge a capacitor, you can use a resistor to slowly drain the stored energy. Connect the resistor across the capacitor terminals and wait for several minutes to ensure that the capacitor is fully discharged. Once the capacitor is discharged, you can safely remove it from the motor. When installing the new capacitor, ensure that it is properly connected to the motor windings. The capacitor terminal should be securely attached to the corresponding wires, and the capacitor should be mounted in a location that provides adequate ventilation. After installing the new capacitor, double-check all connections and ensure that the capacitor is properly secured. Then, restore power to the air conditioning system and test the motor to ensure that it is running properly. If the motor starts smoothly and runs at its normal speed, the capacitor replacement was successful. In conclusion, replacing a capacitor in an air conditioning blower motor is a relatively straightforward task that can be accomplished with basic tools and knowledge. However, it is crucial to follow safety precautions and select the correct replacement capacitor to ensure the efficient and reliable operation of your air conditioning system. If you are not comfortable performing the capacitor replacement yourself, it is always best to consult with a qualified technician. Now let's delve into some additional tips for ensuring a successful capacitor replacement. Firstly, it's always a good idea to take a picture of the original capacitor's wiring configuration before disconnecting it. This will serve as a helpful reference when connecting the new capacitor. Secondly, when selecting a replacement capacitor, consider the operating temperature range. Air conditioning blower motors often operate in high-temperature environments, so it's important to choose a capacitor that can withstand these conditions without degrading or failing. Thirdly, when installing the new capacitor, make sure to use properly insulated connectors to prevent short circuits and electrical hazards. Fourthly, after replacing the capacitor, it's a good practice to check the motor's amp draw to ensure that it is within the manufacturer's specifications. An abnormally high amp draw can indicate a problem with the motor or the capacitor. Fifthly, if you're not sure which type of capacitor your blower motor uses, consult the motor's wiring diagram or contact the manufacturer for assistance. Using the wrong type of capacitor can damage the motor and void the warranty. Sixthly, when disposing of the old capacitor, follow local regulations for proper disposal of electronic waste. Capacitors may contain hazardous materials that can harm the environment if not disposed of properly. Seventhly, consider upgrading to a higher quality capacitor for improved performance and longevity. Premium capacitors often have better temperature ratings, lower ESR equivalent series resistance, and longer lifespans. Eighthly, if you're experiencing frequent capacitor failures, investigate the underlying cause of the problem. Overheating, voltage fluctuations, and excessive vibration can all contribute to premature capacitor failure. Ninthly, remember to keep the blower motor and surrounding area clean and free of debris. Dust, dirt, and other contaminants can accumulate on the capacitor and reduce its cooling efficiency. Finally, if you're not comfortable working with electrical components, it's always best to hire a qualified technician to perform the capacitor replacement. A professional technician will have the knowledge, skills, and tools to safely and effectively replace the capacitor and ensure that your air conditioning system is running smoothly. Now, let's discuss some of the common misconceptions about capacitors. One common misconception is that a larger capacitor is always better. However, using a capacitor with a higher capacitance value than the original can damage the motor and reduce its efficiency. Another misconception is that capacitors last forever. In reality, capacitors have a limited lifespan and will eventually degrade and fail due to factors such as heat, voltage, stress, and vibration. Another misconception is that all capacitors are the same. In fact, there are many different types of capacitors, each with its own unique characteristics and applications. Using the wrong type of capacitor can lead to poor performance and premature failure. Another misconception is that capacitors are only used in air conditioning systems. In reality, capacitors are used in a wide variety of electrical and electronic devices, including motors, power supplies, and audio equipment. Another misconception is that capacitors are always easy to replace. In some cases, capacitor replacement can be challenging due to factors such as limited access, tight wiring, and unfamiliar components. Another misconception is that capacitors are always expensive. In reality, capacitors are relatively inexpensive components, and replacing a faulty capacitor is often much cheaper than replacing the entire motor. Another misconception is that capacitors are not important. In fact, capacitors play a crucial role in many electrical and electronic circuits, and a faulty capacitor can cause a wide range of problems. By understanding the common misconceptions about capacitors, you can avoid costly mistakes and ensure that your electrical systems are operating safely and efficiently.